Welcome to the fourth video for Unit 4 over covalent bonds. The number one takeaway from this video is that a covalent bond is between a nonmetal and a nonmetal. So the elements that are involved in covalent bonds can be found on the right side of the staircase on the periodic table. So let's talk about this in a little more detail. Okay, so a covalent bond is when you have two or more electrons that are shared between nonmetals. And the reason that this occurs is that there is an attraction between the nucleus of an atom to another atom's electrons. That's basically what electronegativity is, the ability to attract electrons due to your positively charged nucleus. So an example of this, we have two atoms with their positive nuclei, and they've got the electrons surrounding them. So what will happen is they will share a pair of electrons between them, and the reason this happens is because one atom, like say this one, maybe is very electronegative and it pulls in these electrons. And so one thing you need to definitely take away about this definition is that it's always in pairs, two or more. So it's either by 2 or 4 or even 6 electrons can be shared between two atoms. So make sure you write this definition down before you go to the next slide. Okay, so whenever you have a covalent bond, there are two things that can be created. You either are going to have a covalent bond that is polar or a covalent bond that is nonpolar. Basically, it all has to do with how these electrons are shared. When it is a polar bond, that means it is unequally sharing those electrons. Someone or some atom is pulling on those electrons a little bit more, and when it does that, it creates what's called a dipole, which is basically a positive and a negative end. Think of the poles of the Earth, the north and the south end. And the opposite of that would be a nonpolar bond, which is basically you're sharing those electrons equally. Usually that happens due to equal electronegativities. So how can you determine if a bond is polar or nonpolar? You have to do a little bit of math. All you have to do is get the difference between the two electronegativities of the atoms that are involved. Electronegativities are not something you have to memorize. They are something I will always provide to you. So whenever I give you the two atoms that are involved, you just get the difference between the two, meaning the larger number minus the smaller number. And based on that difference, it's going to fall somewhere on this scale. So if the difference is from 0 to less than 0.5, it's going to create a nonpolar bond. If it falls between 0.5 and 2.1, that's going to create a polar bond. So those, remember, are two different types of covalent bonds. Now, if the difference is great enough to be greater than 2.1, then that's going to create an entirely different bond, which we talked about in the last video, which is an ionic bond. Recall that ionic is between a metal and a nonmetal. So we said that the electronegativity difference was so great between those two that it'll create an ionic bond. So what we're going to be doing in class tomorrow is we're going to be drawing what are called Lewis structures. Remember, this is where we draw the valence electrons around atoms. And there are 5 steps that you need to memorize when you draw the Lewis structures of covalent compounds. You need to pause this and copy these all down. So the very first one is you need to count the total number of valence electrons. Remember, you just got to look at the group that that element is in, and that will tell you the number of valence electrons that atom has. So once you've counted all these up, you're going to place one of those atoms in the middle. The least electronegative atom goes in the middle. Unless carbon is present, carbon will always go in the middle. Hydrogen never gets to go in the middle. And once you do this, you're going to connect all these atoms to the central atom by creating bonds. The next thing you're going to do is you're going to distribute your extra valence electrons to all the outer atoms of that structure and make sure that everyone has the octet rule satisfied, which means everybody wants 8. But recall that hydrogen only wants 2 in order to be happy. The fourth step, if you have any more extra valence electrons, you just put those on the central atom. Now here's where you need to double check. And the step number 5, you need to make double or triple bonds if needed in order to make sure that everyone has 8 without going over the total number of valence electrons you have available. So make sure you have all these rules copied down, and we will be using these in class tomorrow when we draw Lewis structures of covalent compounds.